All right, no time for summaries things. We're diving right in. Adding vectors, oh, you just add them up. It's the easiest thing ever. You literally just take the numbers and you add them up. You want to subtract vectors, you just subtract them. You take the x's, you subtract them. You take the y's, you subtract them. You take the horizontal components, you subtract them. Take the vertical components, you subtract them. You want to multiply uh, by a scalar, just multiply numbers by that number. It's easy peasy. It's there's literally like no fancy tricks, no nothing. You just do it. Just do it. So check this one out. We want to multiply u apparently. Oh no, are they all going to turn red? I don't know. We want to multiply by u by 3. So you just multiply those two numbers by 3. 2 times 3 is 6. And -1 times 3 is -3. That's it. Oh, I'm sorry. I want to keep it as a vector, please. A little cornery thing. Then we had a little plus, so plus. Then we had this other vector, v, with -5 and 5. It's got to be multiplied by 1/5. So -5 times 1/5, that's just -1. 5 times 1/5, oh, that's just 1. That's it. Okay, now they want us to add these two vectors together. Couldn't be easier. 6 plus 1 plus -1. 6 plus -1 is 5. And then -3 plus -1, -2. Done. That's it. That's all you gotta do. I mean, any other writing I do is I feel like a waste of time now that you're watching this video. So, but that's all you gotta do. It's pretty easy. There is something that we need to be careful of. Multiplication works weird because we did a number times a vector. This is where it actually starts getting interesting. It's this thing called the dot product. And it's when you're multiplying, in a sense, vectors together. It doesn't follow the same idea. It actually works out kind of weird. If you take vector dot product another vector, so vector dot vector, you get a number. You don't get another vector. So it doesn't create some new vector. You take those two, and when you dot product them, they become a number, and they're no longer a vector. Fun fact with the reason that we're going to use this is you can use it to find the magnitude. You can find the magnitude of vector if you do its dot product with itself. So if you do u dot u, you end up with the magnitude of u, which is a number. And that's what you're supposed to get after you do a dot product. It spits out a number. So that's what it will do. So let's try one out. So I've got these two. I would like to find the dot product of these two vectors. So what you need to do is you need to multiply the x's. So we'll do 7 and -2. So I'm sorry, -7 times 2. And then we're going to do these two multiplied together. So 3 times 5. And then you just, according to the rules O dot product, you just add them up. So we get -14 plus 15, abandoning colors and times of speed, and we get 1. That's it. Now the secret of what you're doing here, this is the Pythagorean theorem. You can see it if you do a dot product of something with itself, which you're going to see in just a moment. Because what this is really used for, this dot product idea, is if we had two vectors, we want to find the angle in between them. There is a way to do this without this goofy formula, but it involves like the law of sines and the law of cosines and a bunch of weird stuff. It's not worth it. This formula is just too good. I'm sorry, it's just too good. It's not worth me showing you the other way. This angle between vectors is really, really cool. So to find the angle between two non-zero vectors, you use this goofy formula. FYI, this is the only formula that I'm going to put on the test. So you'll have this formula available. You don't have to have that memorized. It's just a goofy formula that we're going to use. So you're going to do u dot v, and you're going to divide that by their two magnitudes multiplied together, and it equals the cosine of the angle between them, which is pretty neat. Here we go. We're going to try it out. So I want to find the angle between these two vectors. So there, I wrote my little formula there. I need to find the magnitude of both of these things. Just for argument's sake, I'm going to say this one is u and this one is v, which makes sense because one of them is the first one of them is the second one. I need to find the magnitude of u. So I just need to do the dot product of u with itself. So you got 2 squared plus negative, 2 squared plus 9 squared. Oh no. Have you been looking like now I've got that pop up earlier. I messed up. This is our magnitude squared. It's not actually the magnitude, it's the magnitude squared. It's too late. I shouldn't be doing these videos so late. So let's see. We should just get our magnitude squared, not our magnitude. Oh, I'm sorry. I'm just gonna leave that groaning in there so you can see me suffer. So our actual magnitude is going to be the square root of 4 plus 9, which is 13. And magnitudes are positive because they're the hypotenuse. So we always wanted to keep those hypotenuses positive, our radii positive. Got to find the magnitude of v. Dot product of it with itself. It's even more obvious, hopefully now, about how we're doing the Pythagorean theorem. Look at that. Dot product, Pythagorean theorem, same thing. Magnitude of v is the square root of 16 plus 9, which is 25. Oh, that's a nice number. Oh, no, I don't need a squared there. So the magnitude of v is just 5. Okay, so let's put that in. So the cosine of whatever the angle is between these two vectors is going to be their two magnitudes. So square root of 13 times this times 5. There are two magnitudes. And then on the numerator, I got to do their dot product. So I got to do 2 times negative 4, that's negative 8, plus negative 3 times 3, which is negative 9. So I get the cosine of theta is, let's see, negative 17 over 5 square roots of 13. 5 square roots of 13 is real gross. We're just going to leave it gross because we're about to put it into cosine. It's going to get gross anyway. This chapter has gross numbers. So theta is going to be the inverse cosine of negative 17. Get out of the way, me. 18.027. All right, so I'm going to go to my calculator. I'm going to type that in. So I want inverse cosine of negative 17. Oop, that's a minus, not a negative. Divided by the answer that I just got. Second answer, enter. 160 degrees. Cool. 0.560 degrees. Done. We have found the angle between. So that's operations with vectors. So dot product, it's not regular multiplication. You have to multiply the first two things, multiply the last two things, add them together. When you're adding vectors just willy-nilly, just add them willy-nilly, just x's and x's, y's with y's. Multiply by a scalar, just multiply all the numbers by that scalar. And that's about it. Also, final thing, dot product, just Pythagorean theorem. That's all it is. Okay, thanks for watching.